In section 4.1 video, we're going to be talking about exponential functions. And I'm going to give you a general shape of the graphs here. And this usually looks like f of x or y equals something with an exponent, of course. And something you have to keep in mind with exponential functions is that we have something called an asymptote. And an asymptote is an imaginary line that the graph gets closer and closer to. So if you notice over here in this graph, our asymptote will be this imaginary line here because our graph gets closer and closer and closer to it, but maybe never touches it. We don't know. So we're going to practice with a couple here. Remember, for your homework, you can sketch it to make it go faster. So all I'm going to do is go to my y equals and type in 2 to the x power. And when you do that, we get a graph that looks like that. And again, if we go ahead and graph this one over here, we're going to type in our y equals 5 times 2 to the x power. And it's going to be exactly the same looking, except for it's going to shoot up in a faster, it's going to shoot up faster. So, and that's because it's multiplied by 5. So the graphing is pretty easy. We also are going to state the domain and range. So here are a few examples of those. So again, you can just sketch these on your homework. And what we're going to do is, I'm going to show you how to plug this in your calculator because it is a little different. When you're talking about something with an exponent, it is very easy to just plug in. However, when you have an exponent that has a few things within it, such as the one I just showed you, x plus 2, you have to put parentheses around the entire exponent so the calculator knows the entire thing is indeed an exponent. So I'm going to go ahead and plug this stuff in, which was -3 times 2. And it is raised to parenthesis x plus 2, and then close your parenthesis. And when you go to graph, that is what the graph should look like. So you can sketch that on your paper. Now, one thing that we need to look at is our domain and range. Let me switch back here. When we're talking about domain and range, let me just sketch this real quickly. We're talking about the x and the y values. Remember, the domain is all of your x values and range is all of your y values. So the domain for this one is asking, what are all of the x values doing? Does it cover the entire spectrum, meaning the negative and the positive? So does this graph go into the negative side and the positive side? And the answer should be yes. So all real numbers are included here. And that's exactly what we'll write. Now when we're talking about the range, we're asking ourselves, what about the y? As you can tell, this graph definitely goes to the negative side of y, but it never goes up here. In fact, it stays below that asymptote that I was talking about. And so the way we do the range here is we'd have to say y is either less than or equal to 0, because this line here, of course, is 0. Now, we can go ahead and put the less than sign, but the way to tell if it does, in fact, touch 0 is to look at your x and y chart. So if you go to your table, you can see that all of these numbers on the y side are very small, and they just keep getting smaller and smaller, so they never really touch 0. So if they do not touch 0, we're going to leave that little line out of this. So there's your domain and range. Okay, now the next one. Again, when we go to sketch this, we want to make sure that we put parentheses around the entire part of the exponent. Otherwise, the calculator will not say, oh, x minus 2 is part of the exponent, unless those parentheses are around there. So when you go through and you type in 3 raised to parenthesis x minus 2 parenthesis minus 1 and hit graph, your graph ends up looking like this. And we now have to state the domain and range. If you look at the domain, we're talking about the x values. Does this graph go on the positive side of x and the negative? The answer is yes. So we've got all real numbers. And when we talk about the range, we're talking about, you know, the asymptote. So if you look, we have an imaginary line, really, that graph stays above. So we're going to write y, and this graph is above it, so we're going to write more than. I'm not sure if it's going to be equal to it yet, and this is where you need to figure out what is that number. So if you go back to your calculator, and I need to plug this in, so give me just a second. If you look in your table, you can tell that that number is -1. It never goes past it. And it also touches it. So, and this is just the graph starting to go down. So that number for our range here should be a -1. And because it was listed in the x and y chart, we want to include it this time. All right, the last thing in this chapter is about compound interest, and this is the real life application here. Compound interest formula is this equation. And if you want to pause the video, you can, so that you can write down exactly what each one of these stands for. So here's an example. You deposit $800 into an account that pays 2% annual interest compounded daily. Write a model. Now, here are some words that you might not understand. The word compounded. The word compounded means what interest or what amount of money are they putting into your account just for having a savings account. So when we talk about compounded daily, that means every single day they are putting a certain percentage of interest or money into your bank account. And in this case, they're putting a 2% interest. So the key things that we need to is the $800, the 2%, and then the compounded daily. And it says write a model. We're not even actually going to figure out how, what amount of money we're going to have after so many years. We're just writing a basic model so that if somebody was to come along and say, what is the amount of money I could get after 10 years? They could plug in 10 and then just calculate it. So the first part of that equation, remember, is your P, which is your principal, the starting amount. So that's going to be your $800. And now we have the R. And remember I said the R has to be expressed as a decimal. So we write 2% as a decimal. The decimal starts here and we go back twice. So it's actually 0.02. And we're going to divide that by n, which is the number of times being compounded. Because this is daily, there are 365 days of the year. So that is how many times that they are putting interest into your account. And then following the formula, we write the n again. And then the t in years. And because we don't know what the t is, we'll just leave that as a t. Kind of open for anybody to plug in any number of years to figure out how much money they have left over. So this is just the general formula, and if it said in the book to write a model, this is where you would stop.